Hello everyone, I am Pranali Patil and today we'll be discussing a fundamental concept in machine learning, that is distance matrix in KNN. So, have you ever wondered how our system classifies the email as a spam or not spam? Let's see how it actually works. So before moving to our core topic, let's see what is KNN. KNN is a machine learning algorithm which classifies the new data point based upon its similarity with the existing data points. For classification, it uses a majority vote, and for regression, it takes an average vote. So, how it basically works? It measures the distance between two data points by using a distance matrices, which is our topic of the discussion, and if they are closer, the distance is minimum, then they are similar to each other, so they cluster at one point. So yeah, KNN algorithms entire logic of finding neighbors are depend on the distance matrices. If distance matrices are directly impact on the data points of the data set, different matrices are designed for the different data sets. For example, here we take an example of the document classification. If we use a Euclidean distance for that, it will give us a 65% of the accuracy. And if we change the matrix to a Manhattan distance matrix, then it will raise the accuracy up to 91%. So yeah, it matters to choose a right matrix for the right data set. So let's see what is this Euclidean distance and Manhattan distance actually. So yeah, these are the types of the distance matrices: Euclidean distance, Manhattan distance, and Minkowski distance. Euclidean distance is mostly used distance matrix. It will measure the straight line distance between 2 points. Like here we can see in a diagram, the blue line indicates a Euclidean distance. So yeah, if we take a real world example, if you have to go from one point to another point, we simply search it on map and it will give us a distance, direct road to reach at that point. It is good for the numeric and the simple data. So next is a Manhattan distance. We can also call it as an L1 distance. So it basically means sum of the absolute differences between points across all the dimensions. Means we cannot directly measure the distance diagonally like a Euclidean distance. We have to measure the distance along with the axis, like the diagram indicates. We won't directly measure the distance between A and B. We have to go through point C to measure the distance between 2 points. And Manhattan distance is good for the outliers which present in the data set. Then third one is Minkowski distance. It basically a generalization of both Euclidean distance and the Manhattan distance. Means it introduces a variable p. If the value of the p is 1, then it work as a Manhattan distance matrix, and if the value of p is 2, then it works as a Euclidean distance. Let's see how it actually works and how the formulas of each of the distance matrices. So yeah, we take in step 1, we'll take a 2 points in n dimensional space. Then in second step, we find the differences between each coordinate. For that, we will take a 3. We have a 3 options, mean 3 distance matrices. First one is Euclidean distance. As we have discussed, we measure distance directly through a straight line. It is basically based on the Pythagoras theorem. The formula is square root of x minus x1 bracket square plus y minus y1 bracket square. Here we measure a direct distance between A and B. In Manhattan distance, we have to go through the axis or the grid that we have to follow. So yeah, here the formula is absolute difference between x minus x1 plus absolute difference between y minus y1. What absolute difference means is it return a positive scalar value even if it is a negative. And yeah, Last one is Minkowski distance. If P is equal to 2, as we have discussed, it will act as a Euclidean distance matrix, and if P is equal to 1, it will act as a Manhattan distance. So formula is I, summation of I goes from 1 to n is the dimensions, and absolute difference between xi minus yi raised to p and whole bracket raised to 1 upon p. So from from these three, we use one distance matrix, and it will return us a single scalar value. And in step 3, what we does that we classifies it, means we define it how similar or dissimilar the data points are. So yeah, and based on that, we make a clusters in KNN. So let's see what are the challenges we have to face. So first challenge is curve of dimensionality. If there is an n-dimensional or high dimensional space, then the distance between all the data points become nearly equal. So yeah, this is one challenge. Then second one is sensitivity to feature scaling. So the data points, some data point ranges are very large, and that can dominate the distance calculation. So we have to normalize it by using some techniques of the machine learning. The third one is inappropriate for categorical data. So the distance metric like Euclidean distance cannot directly apply it to the non-numeric data, that is categorical data. For example, city name, colors. So we have to convert it into numeric data by using some techniques in machine learning like one-hot encoding and all. So yeah, and last one is no single best matrix. So it is very important to choose a one best matrix for the one data set. So that is the one of the most faced challenge in KNN. So yeah, here is example given of the feature scaling. Age and the salary are the two features, and we have to scale them into one range by normalizing it. So it won't, it data set won't look like left skewed or right skewed. It is it just normally distributed. So yeah, at the end we'll see the summary. So distance matrix is a crucial parameter used in the KNN for the data similarity. So choosing a right matrix from three of them is very difficult. So for that, we have to understand the data, we have to understand the patterns, we have to try and error to choose a right matrix for the particular data set. Then before applying any matrix to the data set, we have to pre-process that data, we have to feature scale that data, we have to normalize that data to prevent the skewed result. So yeah, understanding the strengths and weaknesses of the matrix is essential for building an effective and accurate KNN model. So best practice is to scale the data first, pre-process the data first, and start from the basic matrix, distance matrix, and the remembering thing for using the distance matrix is the goal is not just to pick a matrix, but to choose one of that best represent the true similarity between it. Thank you.